In this video, I'm going to do an example where I solve a polynomial equation. So notice this is a cubic polynomial equation because our highest exponent is 3. This polynomial equation is a little bit different than the ones I had done in previous examples or in the previous video because one side is not equal to 0. It's the same situation as what would have happened with solving quadratic equations. If one side is not equal to 0, you have to make one side equal to 0. So step 1 is to set one side of equation equal to 0. And the way you're going to do that is just simply rearrange the equation so that one side has nothing on it, so that one side is 0. So I'll decide to make this side equal to 0, so I'm just going to have to subtract the x cubed from both sides, subtract the 3x squared from both sides, and add a 10 to both sides. So on the left side, I'm going to have what I already had, and then I'm going to subtract x cubed from both sides, and by subtracting it from this side I get rid of it here. Subtract 3x squared from both sides, which will get rid of it here, and add 10 to both sides. When I do it here, I'll just get rid of it, so that on the right side all I have left is 0. Now I will collect like terms. So same thing you would do with quadratics. So I have 3x squared, 3x cubed, sorry, and minus x cubed. So I have 2x cubes. I have minus 4x squared, minus 3x squared, minus 7x squared. I have minus 17x, it's the only x term, and plus 10, it's the only constant term. And that's equal to 0. So that's good. I have a polynomial, a cubic, written in standard form. So now what I'm going to do is factor. That's the same thing you would do with a quadratic, if possible. Before I factor, I'll just mention, if you recall with a quadratic, if you weren't able to factor, you could always go to the quadratic formula. We're not going to be able to do that for cubics and higher degree polynomials. The only method we're going to have is factoring. So how do you factor a cubic? Well, you use the factor theorem. So in order to use the factor theorem, we're going to have to say let p at x equal 2x cubed minus 7x squared minus 17x plus 10, and we want to figure out what number can we evaluate this function at such that p at that number is 0, because that would mean that x minus that number, right? Recall that x minus a is a factor if p at a equals 0. This is basically the factor theorem. And the way we're going to decide on what values to try for a is first we would try numbers that are factors of this last number. So always 1 and negative 1 are good guesses. 2 and negative 2 for this one, because 2 and negative 2 divide 10. Negative 5 and 5 also divide 10. If those don't work, notice this one also has a coefficient on the first term. So you might have to divide these things by numbers by factors of this, which are just 1 and 2. And obviously you don't have to try dividing by 1 because that's these numbers here, but you might have to divide these numbers by 2 and try those first. But I would always try these numbers first. Just to save myself some time, I already know which one works. I made the question up. So I'm going to try, just as a lucky guess, p at negative 2. Okay. You probably wouldn't have guessed negative 2 first, right? You might have tried 1, negative 1, and 2 first. Suggestion, you don't actually have to write all the steps down when you try 1. Just, if you can, do it in your head and see if you get 0. And if you don't, just move on. If you do, show that it works by writing it down. But I'm going to try -2 first, and I'm reasonably confident it's going to work. So by work, I mean it will give me 0. So I'll sub -2 in for x. So that would be 2 times -8 minus 7 times 4 plus 17 times 2, which is 34, plus 10. -2 times 8 minus 16. 7 times 4, so subtract 28, plus 34, plus 10. -16 minus 28 is minus 44, plus 34, so we're at -10. Add 10, we get 0. So that tells me that p at -2 equals 0. Therefore, by the factor theorem, what would that be? X plus 2 is a factor of p at x. So that means we can do some long division and divide x, and x plus 2 will divide 2x cubed minus 7x squared minus 17x plus 10. So we'll have to do that. What times x gives us 2x cubed? That would be 2x squared. 2x squared times x plus 2 is 2x cubed plus 4x squared. Subtract. These two will give you 0. These two will give you -11x squared. Bring down the next term. Minus 17x. What times x gives you -11x squared? That would be minus 11x. Multiply minus 11x times x plus 2. Will give you minus 22x. Subtract. That will give you 5x. Bring down the 10. Multiply by positive 5. 5 times x plus 2 is 5x plus 10, which is good because now when we subtract we get 0, which is what we should get. So the remainder is 0. Therefore, we know that 2x cubed minus 7x squared minus 17x plus 10, which remember is what I'm just going to go back to the original equation, right? We're trying to solve this equation here, which is what I've rewritten here. Well, we know this thing is equal to x plus 2 times this term, this one here, 2x squared minus 11x plus 5. Now we don't have it in factored form completely, but it's partially in factored form. We have one factor. Now, if possible, we're going to try to factor this one. You might not be able to, right? Not all quadratics are factorable, but let's see if we can do it. So let's, by using trial and error, see if you're able to factor this one. Or if you couldn't use trial and error, you could try the quadratic formula. It might not be nice factors, so you might have to go to the quadratic formula. Or it's possible if you try the quadratic formula, you'll get a number that doesn't work. So if this works, because the first term is 2x squared, I know that the only way to get 2x squared would be to multiply by 2x and x. So if this is going to work, it's going to be 2 and 1. And over here I have 5 and 1 is the only factors of 5. Although actually negative 5 and 1 and positive 5 and negative 1 also work. And I know it's going to be negative because this one's negative. So now I'll just try multiplying. Let's see, 2 times negative 5 is negative 10. That's not going to work. Oh, I'm sorry, they would both have to be negative. They would both have to be negative. So really I just have to try the negative ones. Right, because it multiplies to a positive number, of course. 2 times negative 5 is negative 10. 1 times negative 1 is minus 1. Add those together, you get negative 11, which is what we wanted. So 2 we want to multiply by negative 5, so the negative 5 goes here. And 1 we want to multiply by negative 1, so that goes here. So now that original equation's been reduced to this polynomial equation in factored form, which is equal to 0, which means x plus 2 equals 0. 2x minus 1 equals 0, or x minus 5 equals 0. So 3 simple linear equations to solve. So x equals minus 2. This would be 2x equals 1, or x equals 1/2, and x equals 5. Therefore, the solutions, or the roots to the original equation is x equals negative 2, 1/2, and 5. So there's 3 solutions. So looking back at what the original equation was, where was that original equation? Oh, I've gone too far. Here's the original equation. Right here. 3x cubed minus 4x squared minus 17x equals x cubed plus 3x squared minus 10. So if you wanted to check that negative 2, 1/2, and 5 worked, right? We said the solutions were x equals negative 2, 1/2, and 5. You could just take this x value, put it into the x, and check that left side equals right side. I'm not going to check, but it would be a good exercise. If you wanted, you could do it. Put in 1/2, make sure you get the same on left side, right side. Put in 5, make sure you get the same thing, and you will. I've already checked. So that's how you solve a polynomial equation. Not a short process, but it's the same steps really as solving a quadratic. The only problem is this step here, factoring for a polynomial, is a lot, more involved than just factoring a quadratic. A quadratic you can often factor in one line, but when you're factoring a cubic, it often takes you a long time because you have to use the factor theorem. You have to guess a factor and then do long division and then factor further. So it takes a little bit longer than solving just a quadratic. Well, maybe a lot longer, but you're following the same sort of procedure.